The human genome has 6.5 billion pairs of single letter codes. If we print off this code, it will go from Morgantown, West Virginia to Cape Town, South Africa. To help us better understand this long code, we use the baker's yeast. Its genome is smaller and is more manageable. But what makes individuals different from one another? 4 letters, A, T, C, and G, is what gives us our father's eyes, our mother's freckles, or genetic diseases such as Down syndrome. Biologists have spent lifetimes studying the genetic code, trying to figure out what makes you, well, you and me. Last year, 35 million people were admitted to the hospital in the United States. That is the entire population of Canada. 2.5 million of those people got infections from being at the hospital. But why? For many of these, devices inserted into them to help them breathe and to use a bathroom are major sites of infection. Copper is a natural antimicrobial and it has a low toxicity to humans. Nanotechnology today has slowly improved their livelihoods, and you directly interact with nanoparticles from the ingredients in your toothpaste to sporting goods equipment and to chips in our computers. But what is nanotechnology? Nanotechnology takes familiar items such as metals and uses them in a way that they're small enough to gain unfamiliar properties. Everyone knows the color of gold. Whenever you take gold and use it in a nanoscale, you get different colors of red. And this is often seen in stained glass windows. Today, West Virginia's timber industry is thriving. But what do we do with all the sawdust? This waste material can be used to create natural nanotechnologies. If we add copper to this nanotechnology, we can create antimicrobial, natural nanoparticles. These can also be used in plastics. It has been established that this antimicrobial nanomaterial is more toxic to microbes than traditional copper. How is this new antimicrobial more toxic than traditional copper? And what roles do the genes play? This is the question my dissertation aims to answer. I take apart genes from the genetic code of yeast, much like a kid takes apart a toy. What we have found is that the way yeast take in and store this nanomaterial is different than traditional copper. This is exciting, and the potential for this nanomaterial is amazing. Ultimately, my research aims to help reduce or eliminate infections from insertable devices in the hospital setting. Thank you for your time.